Alright, in this video, we're going to go over graphing rational functions. Alright, graphing rational functions is actually quite simple, because all you do is take what we've already learned and just apply it to the graph. Alright, so the first thing to always do when you graph a rational function, the easiest thing to always do is find your horizontal asymptotes. Alright, if you remember that chart, all you do is you look at your degrees of your top and your bottom. All right. In this case, they're both 2, so they're the same. So that means it's just the leading coefficient of the top divided by the leading coefficient of the bottom. So it's just simply y equals the leading coefficient of the top is 1, the other one is 1, so your y-intercept is 1. So that's the easiest thing to do. The second easiest thing to do is find your vertical asymptotes. Remember, your vertical asymptotes is where the bottom of your function equals 0. All right, so let's factor this out. All right, x squared minus 4, well, that's a special case, a squared minus b squared. So that comes to x plus 2 and x minus 2. And let's factor the top. So we need something that multiplies to 12 and will add to 1. When we know this has to be x and x, we know we have to have one of each. Because this is negative, so we have one of each. Well, 12 is either 1 and 12, 2 and 6, or 3 and 4. 3 and 4 is the only way you can get a 1, and since this is positive, the 4 will go there. That was supposed to be a 4. And the 3 will go here. All right, we can't cancel anything out of the top and the bottom. So we don't have any non-removable discontinuities, so we don't have any holes. So therefore, we have vertical asymptotes. Since we don't have holes, we have vertical asymptotes. And to find them, remember, you just take the bottom of your function, each factor individually, and set it equal to 0, solve for x, and those are your vertical asymptotes. I was about to write v for vertical asymptote. So at x equals negative 2, and if you add the 2 over here, you get positive 2. So we have vertical asymptotes at negative 2 and positive 2. Alright, so now the next thing we can do is find the x-intercepts. Well, if you remember, the x-intercept is where the numerator of your function equals 0. That's all we're worried about for x-intercepts. Okay, is where where the top equals 0. So since we already have it factored, we have x plus 4, set that equal to 0. And we have x minus 3, set that equal to 0. So we get x equals negative 4 and positive 3 as our two x-intercepts. Okay? So before we move on, let's go ahead and graph some of this over here. All right, let's go ahead and graph some of this. So we know we have a horizontal asymptote at y equals 1. So here's y equals 1. Let's draw our vertical asymptote. I know it's supposed to be dashed. Give me a second, and it will be. All right. Let me extend this a little bit more. All right, now let's make it dashed. So there's our horizontal asymptote. Now let's draw our vertical asymptotes. We have x equals negative, we have x equals negative 2. So we have one here. And let me make that dashed. Alright. I'm also going to clone that because we have another vertical asymptote at positive 2. Alright, so there's our horizontal asymptote, which we solved for, y equals 1. So this is simply the line y equals 1. Here's our two vertical asymptotes. All we did to get them was we simply set the bottom of the fraction equal to 0, and we solve for x. So we got x is positive negative 2. So this is the line x equals negative 2. This is the line y equals positive 2. All right. So now we know that. We know our x-intercepts. We have our x-intercept at negative 4. So negative 2, negative 3, negative 4. There's one x-intercept. And at positive 3, so at 1, 2, 3, here's our other one. All right, so there's our two x-intercepts. Now we can find the y-intercept. Remember, to find the y-intercept, you just simply set all your x's equal to 0. So let's go to this first function. We're going to have 0 squared plus 0 minus 12 over 0 squared minus 4. Well, of course, all of this here is irrelevant. So negative over negative, it's positive. 12 divided by 4 is 3 over 1, or just 3. So our y-intercept is at 3. So 1, 2, 3. So there's our y-intercept. So now what we can do is we can just find a few more points on this graph. Let's do 1, 2, 3. Let's do x equals negative 3. So x in a y chart. I don't know why this is crooked. So plug in negative 3. If you plug it in here and solve for y, you get negative 6 over 5. All right, so negative 6 over 5, that's a little over negative 1, so it's going to be about right here. All right, now let's try a point around this. Let's plug in positive 4. So if you plug in x equals positive 4, you're going to get 2/3. All right, so it's going to be, a little over halfway up. So there's that one. All right, now let's do 1 on either side. Let's do positive 1 and negative 1. So if we put in negative 1, you're going to get out 4. And all I'm doing is plugging these numbers in for the x values up here. All right, if you plug in negative 1, you're going to get 4. So 1, 2, 3, 4. And then plug in positive 1. Okay. Plug in positive 1. And you're going to get out 10/3. All right, you're going to get out 10/3, which is a little bit above 3. So 1, 2, 3, a little bit above that. So right there. So what do we do? Well, we graphed our horizontal asymptote first. We found it. You just simply look at your degrees. The degrees were equal, so it was the leading coefficient, so it came out to 1. Horizontal asymptote at y equals 1. Then we found our vertical asymptotes. Remember to find them. It's easiest to factor first, because you want to make sure you don't have any removable discontinuities. Because if you have a removable discontinuity, we got to do something different. Okay, remember we have to redefine the function at it. And that was from last video. But since we don't have any, we don't have to redefine the function at that point. So both of our discontinuities are non-removable, which means they're vertical asymptotes. So we just set them each equal to 0, solve for the x values, and those are our 2 vertical asymptotes. Then we found the x-intercept. We found the y-intercept. We plotted all that. Then we found a point or two around our x and y intercepts. All right, so we went one to the right of both of our x-intercepts, and then we picked one to the right and left of both of those. Okay, so now all you do is connect with a smooth curve. And remember, your graph will not cross nor touch, this is terrible, will not cross nor touch your vertical asymptotes or your horizontal asymptotes. Okay, this is terrible. But you get the point. At a vertical asymptote, your graph here, see, it's getting very horizontal. All right, it's not going to go exactly horizontal because it won't be parallel to it, but it's going to get infinitely, it's going to continuously get close to it. So as x decreases this way, it's going to get closer and closer and closer to that asymptote, but it's never going to touch it. Same thing in this direction. As x increases, it's going to get closer and closer and closer. Same thing here. As y decreases for both of these, they're going to get closer and closer and closer. And likewise up here, as y increases, x is going to get closer and closer and closer. Okay, so they're going to get close to it, but they are not going to touch it. Okay, so that's all there is to graphing these. You figure out your horizontal asymptotes, you figure out your vertical asymptotes, and then you simply plot all that on your graph. Okay, you simply plot it all on your graph. All right. pause the video for a moment and try this one. What is the graph of the rational function y equals x plus 3 over x squared minus 6s plus 5? All right, so go ahead and pause the video and figure that out. All right, that should have been enough time. Hopefully, that is what your graph came out to look like. You should have a vertical asymptote at 1 and 5. You should have a horizontal asymptote at y equals 0. And if you plot a few points, as you can see, you have a parabola down here. You have this curve here, and you have this curve here. All right. Hopefully that's what yours looks like. It should. If not, go back and figure out why it doesn't. Okay. All right. Using a rational function. Now, I'm going to show you a little bit on how to use your graphing calculator to do some of these. Okay. Hopefully you remember some of the things that I showed you on the graphing calculator a few units ago, because we're going to come back and use those. All right, so it says you work in a pharmacy that mixes different concentrations of saline solutions for its customers. The pharmacy has a supply of two concentrations, 0.5% and 2%. The function y equals, and it's given, gives the concentration of the saline solution after adding x milliliters of 0.5 solution to 100 milliliters of 2% solution. How many milliliters of the 0.5% solution must you add for the combined solution to have a concentration of 0.9%? All right. Well, this is actually fairly easy to figure out. Okay. This is actually fairly easy to figure out. Let's flip over to my graphing calculator here. All right. We're going to need to reset the window to match this. Okay. Your x min is 0, your max is 500. X scale you can leave as auto. Your y min is 0, your y max is 0.02, and your scale is auto. All right, so go ahead and reset your scale to that. Pause the video if you need to see that for a little longer. Now what we're going to do for f1 of x or y1, depending on what kind of calculator you're using, we're going to type in that formula that was on the last slide, the y equals the 100 times the 0.02. Okay, so let's get a fraction bar here. So we have 100 times 0.02 plus x times 0.005, and that's divided by 100 plus x. Okay, that's what you're going to type in for your y1. All right, so there's your first function. Okay, we typed it in, so there's our first one. Now, for your second function, what you want to type in is this. It wants to know how many milliliters of the one solution do we have to mix in the other one in order to get a 0.9% concentration. Well, what we're going to do is we're going to take that 0.9% and convert it to a decimal by dividing by 100. So we're going to get 0.009. So our second function is going to be just that line, 0.009. Okay, so there we go. So we have our two functions. Okay, we have this function here, our f1 of x or the y1 of x, okay, which is the function that represents how much of the one you have to mix into the other to get your concentration right. And then our second function is simply the concentration that we're looking for. If we were looking for a 0.07 concentration, instead of being 0.009, it'd be 0.007. So it's whatever concentration you're looking for is the second one, and then your function that tells you how to find it is your first one. Now, at this point, there's a couple ways to do this. You can either look at the table, or you can find the intersection of the two graphs. All right, either one will work. Let's do the intersection. So if we hit Menu and go to Analyze Graph and go to Intersection, okay, since we only have two graphs, we don't have to pick the two graphs because it automatically knows we want those two. Lower bound means you go to the right or below your intersection. Upper bound means you go to the right or above. Okay, so our intersection is 275, comma 0.009. Well, we knew the y value would be the 0.009 because that's the concentration we're looking for. Now, what the x value tells you, that 275, what that tells you is that is how much of the 0.5 solution, 0.5% solution, you're going to have to add to the 100 milliliters of the 2% solution in order to get the right concentration of 0.9%. Okay, you can just simply graph the two functions, find the intersection, and the x value is how much you have to add. Okay, the x value is how much you have to add. So if we flip back over to here, all right, we can confirm this by just simply plugging in the numbers. So our function was y equals 100 times 0.02 plus x times 0.005 all divided by 100 plus x. So we just have to put in 275 for all three of those. Okay, for both of the x's, I'm sorry, there's only two. Plus 100 times 0.005 all divided by, oops, I wrote 100, sorry, 275 over 100 plus 275. And now we just simply solve this out. Y equals, this is going to give us a 2 right here, plus, plug that in your calculator, you should get 1.375, divided by, that's 375. All right, plug that in, and then, 2 plus this divided by that, and you will in fact get the 009, the 0.009. Okay, so that confirms that you're going to have to add 275 milliliters of the 0.5% solution. All right. So that's a quick way to solve some of these. All right, because otherwise you'd have to set y equal to 0.009 and solve for x, which could take a little while. Or you can graph the function they give you. All right. And then you can take the concentration that you're looking for, convert it into a decimal, graph that as well, and just simply find the intersection. And the x-coordinate of the intersection is your amount that you have to add. Okay? All right, I know this video is getting kind of long. Feel free to watch it as many times as you need to. Make sure when you come to class tomorrow, you're ready to work some problems. See you tomorrow.